Hi, want to turn this into this using only free software that includes machine learning tools? It's possible. Let's dig in. Welcome to Deep Sky Detail. Okay, let's do a rundown of the software I'll be using. I'll use Cyrillic and Gimp primarily, but I'll also use Astro and Astro, two machine learning tools I developed for Astro photos. To stack images, I'll use Cyrillic, and I'll remove stars with StarNet++. Links to how to get each of these programs is in the description. So last month I collected about 4 hours of data on the Eagle Nebula. I used a monochrome camera, a ZWO 294mm Pro in bin 2x2 mode, with hydrogen alpha and LRGB filters and a doublet refractor, all on my old trusty Orion Sirius mount. My goal is to bring out the hydrogen data with RGB stars that blend nicely into the nebula. Alright, let's get started. The first thing you'll want to do is open up Cyrillic and load your files. I've already loaded them here, but in order to set things up, you'll need to click Project, New. Click all the filters you used to use in your imaging session and click OK. Also click File and Preferences to tell Cyrillic where to save the final images. There are 3 sections in Cyrillic. I like to think of them as the Session section, the Directory section, and the Processing section. The Session section shows the filters and imaging sessions you've chosen when you created the project. The Directory section just summarizes how many darks, flats, bias, dark flats, and lights you've loaded. And the Processing section is where you'll add your images, change properties, and examine how things are processed. Okay, loading the images is pretty straightforward. In the Sessions section, click on the filter or session you'd like to add images to. I'll click on HA for hydrogen alpha, for example. Click Files to load the files. The easiest way to add files is to drag and drop them from the folder on your machine. So here are all my HA images. I have a total of 41 images and each image is 300 seconds long. I also have about 30 LRGB images at 60 seconds. The next step is to go to your properties and change subsky from 0 to 1. This will perform a basic background extraction on all your subframes before you stack them. If you don't have flat frames, try changing this to 2. I find the default settings are usually pretty good. But if for some reason your stars don't all stack, you can try changing the stacking filter to tell Cyrillic to change how Cyrillic detects stars. Alright, you've done that. Just click Actions, Step 1 Build Directories, and wait for that to finish. It should only take a minute or so. Then click Actions, Step 2 Run Scripts. This will take a bit longer depending on how many images you're stacking. Once you finish stacking, Cyrillic will save the finished files in the directory you specified when you created the project. It will also open up one of the stacked images in Cyrillic if you are using the filters. I'm going to go ahead and open up the hydrogen alpha data first in Cyrillic. Also, you probably want to make sure that your working directory is the same as where it was in Cyrillic to more easily find your images. To do that, all you have to do is click the Home button and select the directory. Let's do a quick auto stretch to see what we've got. Click on the button near the bottom that says Linear and change it to Auto Stretch. You can zoom by using the Control button on your mouse wheel. Pan by using Control and dragging as you left click. So my doublet's optics aren't perfect. The field isn't quite flat on one side, but that's okay. The HA data look pretty good, all said and done. I'm going to zoom out by clicking the Fit Image to Window button. We'll crop the image to remove some of these stacking artifacts. Just make a selection, right-click, and select Crop. Now the first thing I want to do is a background extraction to see how that affects things. Click Image Processing, Background Extraction. I'll click on points around the image that don't have any nebulosity on as sample points. Make sure that RBF is selected and then click Compute Background. Let's see if the image looks better by toggling the Show Original Image button. I think the background extraction did a pretty good job. So let's click Apply. I want to stretch the image now, so I'll select Image Processing and Generalized Hyperbolic Stretch Transformations. Turn off the auto stretch, and in the pop-up window, zoom in on the histogram until you see the edge of the histogram. Left-click on the left edge and set your symmetry point. Move the local stretch intensity up pretty far, and then start stretching by moving the stretch factor slider up. Once you start seeing the nebula, click Apply. Click the 1 button to unzoom the histogram. Now we'll stretch the data again. So if you're just starting out, you may be wondering, why is my image so dark? Didn't I stack a lot of images to add more signal? Well, it kind of depends on how you think about stacking in signal. I've got a playlist that examines the whole controversy. The link should pop up now. You should go check it out. Alright, so now let's turn the histogram into a logarithmic scale by clicking here. See this curve? Let's click on the inflection point, where it stops curving so steeply. This is our new symmetry point. Don't be so aggressive with the local stretch intensity yet, but move it up slightly if you want, and start stretching again. Okay, let's zoom in a bit to make sure we're not blowing out the stars or anything. It looks good to me. Click Apply again. Let's do it one more time. We'll find the symmetry point again by selecting the inflection point again and start stretching. You can keep doing this, and if the bright spots get blown out, we can adjust the highlight protection point. But I'm going to stop here and remove the stars with StarNut++ that you can integrate into Cyrillic. There are a lot of great videos on how to do that from other YouTubers. I'll try to link one in the description. So I'm going to click Image Processing, Star Processing, and StarNet Star Removal. I'm also going to generate a star mask. Now click Execute and wait for it to remove the stars. In your working directory folder, you'll see 2 more fits files, one for the star mask and one for the starless image. Let's keep those in there for now. What I want to do is combine the LRGB data. So I'll head over to Cyrillic again and select RGB compositing. I'll add the luminance channel to the top luminance section, and the RGB filter data to their respective RGB sections. Here I've already done it. If you don't have luminance, that's fine. It should work with RGB data too. Before we close this window, you'll see that Cyrillic has already finished compositing the images. We can go ahead and preview the auto stretch. Here's a lot of green. So let's do some color balancing before we close this window. Click Finalize Color Balance and make a selection of the sky background in the preview. Then click Use Current Selection and then Background Neutralization. It's done a good job, but let's close this window and try to get rid of the green stars by going to Image Processing and remove the green noise. That's much better. Of course, if you like green stars, you can keep them. Check out my video on color for more on that topic. The second video in that series is coming somewhat soon. We need to crop this image too. Let's make a selection, right-click and crop. Now we'll do the background extraction and stretching like we did for the hydrogen alpha, but we won't be so aggressive with the stretch. We'll also remove the stars. So first the background extraction. For the stretching, because this is an RGB image, I'm going to do an inverse hyperbolic sine stretch. Under Image Processing, click Arc Sine Transformation. Move the stretch factor up until you see some star color. It doesn't have to be a strong stretch. Now let's do the generalized hyperbolic stretch. Let's turn log scale off for a second. Left click the edge of the histogram and start stretching. And click Apply. Let's do it one more time. Remember, not as much stretching here. And now I'll run StarNut++. When that's finished, meet me in Gimp. Okay, here I have 2 starless images and 2 starred images. I just opened them as layers. In Gimp, when you open the fits files, make sure that image composing is turned on. Otherwise, the color layers will open as separate files. Also open one of your color images first and then open the other images as layers. That will make sure the color data is open too. Then put the HA data on bottom, the HA stars next, the color data on top, and on top of that, the color stars. I'm going to deselect the color layers for a second. Now I'm going to change the HA star mask mode to Addition. Zooming in, the stars look nice and blended well. You could also use Screen for a bit brighter stars if you'd like. Try things out. Alright, so now we have a problem. The HA layers and color layers were cropped differently in Cyrillic. Luckily, it's an easy fix. Reveal the star mask for the color stars and change its mode to Addition as well. You'll see duplicated stars everywhere. Press the M key on your keyboard for Move It. Click the layer you want to move, and then use the arrow keys on your keyboard to align the stars. Zooming in far gives you pixel-perfect accuracy. Again, I'm just using the arrow keys to make adjustments one pixel at a time. Once that is aligned, zoom out a bit and find the yellow outline of the star color layer mask. See it? Good. Set the color star mask layer to normal. Now make the starless color layer visible. Select it and use the arrow keys to align it to the star mask layer on the left and right side. See right there? I'm 1 pixel away from having it perfectly aligned horizontally. One key press and bingo. Perfect. Scroll down or up and do the same thing vertically. We've aligned your images. Easy. Just go ahead and crop the image. Press R for rectangle select and select the part of the image you'd like to keep. Click Image, Crop to Selection. Everything should still be lined up. I want to hide all the layers except the stretched HA starless data. It looks pretty good, doesn't it? I'm going to stretch this layer a bit more by going to Colors and Levels. I'll move the middle arrow up to bring out the midtones and click OK. Then open Curves again and move the left arrow to the right to bring down the black point. I want to darken the dark areas up a bit, so I'm going to go to Colors and Curves. Hold down Control and click on a dark part within the nebula. Do the same thing in a brighter part and then in the background. The middle point in the curve can now be moved down a bit. I'll also adjust the dark part down too. It's starting to look pretty nice. Let's add some color. Take the starless color image and move it down and make it visible. Let's change the color to LCH color. It's looking a bit salmon pink compared to the original RGB image, so let's add some more red into the color data. We'll use the H-alpha data for this. Go to Colors, Components, Decompose with the color layer selected. Use RGB as the color model. A new tab in Gimp will pop up with the RGB color data split up. Want to add the HA data into the red channel, so go back to the previous tab, select the HA level, and copy it. Then paste it into the decomposed channel. Right-click on the pasted layer and select To New Layer. Change the layer's mode to Screen. Right-click on the layer again and click Merge Down. Now we want to make the brightness of all the layers the same, so find the histogram tab. If we don't see it, click the little arrow and add the tab. We can see that the mean brightness in the red channel is about 0.315, but green and blue are only around 0.18. Let's decrease the brightness of the red channel by using the Levels tool and moving the middle slider down. Keep an eye on the mean brightness. When it is about 0.19 or 0.18, stop. Now we can recombine the color layers by going to Colors, Components, and compose. Compose into an RGB space with the corresponding layers in the correct RGB sections. Paste the new RGB image into the original Gimp tab we've been using and make it a new layer. We've got a lot more color, but it's still a bit pink. So let's go to colors and saturation. You can then increase the saturation if you'd like. Now I'd also like to make this HA RGB layer have the same feel as RGB original. The original, as you recall, had a bit more white in the center. So I'll open up curves again and adjust the curves of the G and B layers up a bit in the center. I'm using the same hold, control, and click strategy I did earlier to set my anchor points. I'll make slight adjustments with curves and levels on the HA RGB level until I'm satisfied. And I'll apply a Gaussian blur to the HA RGB layer to get rid of some of the color noise. Alright, now I'm going to add the HA stars back in. If you want, you can stop here, but I also want to add color into the stars. So I'll right-click and create a new layer from the visible layers. On the color star mask, make it visible and set the mode to addition. Whoa, those stars are really bright and kind of distracting. I want to tone them down a bit, but of course it's a personal preference. Luckily the HA stars are nice and small. We'll use that as a layer mask. Right-click on the RGB star mask and select Add Layer Mask with full transparency. Now click on the HA star mask and copy it. Now click on the layer mask of the RGB stars and paste it. Right-click on the floating selection and click Anchor Layer. Zooming in, I don't see much difference between the HA stars and the RGB stars. That's because in the RGB stars, most of the color is in the outer ring of the star. I still want that color to come through. So click on the layer mask and then go to Filters, Generic, Dilate. Do this 1 or 2 times and then apply a light Gaussian blur to the layer mask. I'm going to increase the saturation of the RGB star mask. Make sure the layer is selected and not the star mask. You should see the stars start to have color. You can repeat this several times if you'd like, but when you're done, apply a Gaussian blur to the RGB star mask. Again, not the layer mask. I know it's confusing. Sorry. But the stars should have some nice color. I think this is a nice effect. It's so colorful, like the holidays. Okay, take a deep breath. We're almost done. Let's flatten the image and save it as a TIFF file. Make sure there is no alpha channel. Let's put this through Astro Sharp and Astro Clean. I've got my program open. This is a development version I'm working on, so I won't use any of the features that aren't in the current version as of September 30th, 2023. Subscribe so you know when this model will be released. I'll go ahead and load the image. It is color, I just want to preview things first. I'll use the PSF model. I know that the PSF of this image is around 4, so I'm going to use a PSF of 3 at first, using the slider that says 70% of PSF and full width half maximum. Let's move around the preview to see how things are going. Well, there is some ringing around the stars, so let's move the slider down to about 2. That seems to work well without any ringing. If you want to, the second beta version is better at sharpening deep sky objects when doing starless images. So you could sharpen a starless image with that if you'd like. Okay, I'm going to hit full image and update sliders for the program to sharpen the whole image. Once done, I'll save it. I want to open the full image, but before I do that, I'm going to hit preview again. Then I'll open the sharpened image. I'll choose the Astro Clean model, which is an AI denoising tool. It is super aggressive. So instead of applying the full model, I'll only apply 50% with the aggressiveness slider. Panning around the preview, it looks pretty good. Now I'll click full image and update sliders. After it's finished, in a few minutes, I'll download the clean version. But what do you think? Did we do well with only 4 hours of data and free software with a doublet refractor? Let me know in the comments. Thanks for watching.